Before watching this video, it would be very useful to watch the video on what is the normal reaction force. The objectives of this video are to understand the micromechanism that causes friction, to understand the difference between static and kinetic friction, and to know how to solve problems involving the effects of friction. So, what is friction? Friction is a type of contact force that acts to oppose motion between two sliding surfaces. The bodies have to actually be in contact with each other and sliding over one another to experience a friction force. Friction is generally high when the surfaces are rough and dry, and friction is very low when the surfaces are very smooth and wet. An example of bodies in contact with rough and dry surfaces is a crate, a wooden crate let's say, resting on concrete. An example of smooth and wet surfaces is, for example, skating shoes, or the metal part of the skating shoes, sliding on ice. Obviously, one case will have a very low friction, and the other case will have a very high friction. There are two types of frictional forces, that is, static friction and kinetic friction. What is static friction? Static friction is the force that keeps a stationary object at rest. It's the force that stops bodies from starting to move. For example, if you had your computer at rest on a table and tried to slide it along the surface by pushing it, it will not move as soon as you touched it with a force. You need to increase that force gradually until suddenly it started to move. The force which you applied in order to get it to start to move is called the static friction force. So, to initiate motion, in order to make the box move, we have to overcome the force of static friction. So our applied force needs to be larger than the static friction force. Newton's third law applies here. If we apply a force, then static friction will oppose that, and these two forces will be equal and opposite. The body will therefore remain stationary. If we increase the size of our action force, of our applied force, then the reaction force, the friction force, will also increase. However, the static friction force has a maximum component, and that depends upon things that we will see in a while. As soon as the applied force becomes larger than the static force component, then the body will start moving towards the right. The direction of the friction force is parallel to the contact surface, but it's in the opposite direction to the applied force. Once the body starts to move to the right, the friction doesn't go away, but it reduces. It is now called the kinetic friction, not the static friction. The kinetic friction, in other words, the friction during motion, is always less than the static friction. So to summarize so far, there are two types of frictional forces, static friction and kinetic friction. Static friction is the maximum force that keeps a body stationary, and kinetic friction is the force of friction when the surfaces are already moving over each other. And the kinetic friction is always lower than the static friction. The kinetic friction is known as Fk, and the static friction is known as Fs. So there are two factors that affect the amount of friction. Those are the size of the normal force and the material's roughness of the surfaces in contact. That is also known as the coefficient of friction. The two factors that affect friction can be expressed in the equation for static or kinetic friction. The friction force is equal to the coefficient of friction times the normal force. It is very rare for the coefficient of friction mu s, to be greater than 1. For ice, for example, the coefficient of static friction between ice and ice is about 0.1, whereas the coefficient of kinetic friction is about 0.03. It's a lot smaller. Let us look at the application of an example. Example is a 10 kilogram box is at rest on a horizontal surface. That's this. The coefficient of static friction between the surface and the box is 0.5. The coefficient of kinetic friction between the surface and the box is 0.2. The question is, what is the horizontal force required to make the box start moving? And what is the horizontal force required to keep the body in motion once it's moving? Well, to start the body moving, we need to apply a force equal to its static friction. We thereby want to find the static friction. So the static friction equals the coefficient of static friction, which we are given as 0.5, times the normal reaction force, which for a 10 kilogram box resting on a surface will be 100 newtons, and that gives a static friction coefficient of 50 newtons. We thereby need a force of at least 50 newtons to overcome the static friction force so that the body can move with constant velocity. If the force that we apply is greater than 50 newtons, which is equal to the static friction, the body will start accelerating. However, now that the body is in motion, then the friction becomes kinetic friction. The coefficient of kinetic friction is lower than that of static friction, 0.2. Doing the mathematics means that the kinetic friction is only 20 newtons. That means that the applied force needs to be only 20 newtons to keep the body in motion. If the applied force is more than 20 newtons, it means that the body will accelerate in the direction of the net applied force. We can complicate the situation further if we consider an applied force, an additional applied force, or somebody pushing down on the crate with a force of 20 newtons. In that case, the gravitational force on a 10 kilogram mass, 100 newtons downwards, plus the applied force of 20 newtons, means that the crate is pushing down on the ground with 120 newtons. Therefore, the normal reaction force now becomes 120 newtons. In this case, the coefficient of friction will remain the same. However, the static and the kinetic friction friction will actually change. The reason is that the normal force has changed. So the static friction force is equal to the coefficient of static friction multiplied by the normal force. But the normal force is now 120 newtons. Therefore, static friction now becomes 60 newtons, and the kinetic friction is now 25 newtons. If an applied force on the box was trying to move it forward, but it was applied at an angle, that applied force will have a downward component and a sideways component. The downward component of the applied force will increase the size of the normal reaction, and therefore the size of both of the static and the kinetic friction. Therefore, it will be more difficult to get the box moving horizontally. If, however, the applied force was acting to pull the crate, then the friction force would be reduced. The reason is that the applied force has an upward component, thereby the normal reaction force reduces. When the normal reaction force reduces, in this case, to 80 newtons, that means doing the mathematics will require a 40 newton force to get it moving and only a 16 newton force to keep it moving. So it's easier to pull objects along rather than to push them if the direction of the force is downwards.